Welcome to the video presentation of Leveraging Error Correction in Voice-Based Text Entry by Talk and Gaze. Why did we use voice in text entry? There are two main reasons for voice in text entry to be advantageous. One is the speed and the other is hands-free nature of voice in itself. However, in spite of the advantage of the speed and being hands-free, it has some disadvantages. Recognition errors, which is one of the most common challenge in voice-based research. And then the disadvantage of not having any spatial information when only dealing with voice in terms of navigation in text entry scenarios. However, in order to overcome the recognition errors and the errors that are transcribed during voice-based text entry, there are several steps taken. One is to identify the error, navigate to the error, and finally apply the corrective measures. In spite of having these steps in error corrections in voice-based text entry, it has been found that 66% of the interaction time is spent in correcting errors, the rest in transcribing it. This is a massive blow to the advantage that voice in itself has with the speed of transcribing. However, there have been research which has taken a roundabout way in improving these challenges associated with error correction. They have added another modality. Some papers like use pen-based gestures, some use gaze, and others stick to the conventional keyboard and mouse along with voice for error correction in voice-based text entry. Gaze as a secondary modality is of primary importance for us, mainly for two reasons. It's exactly hands-free like voice, and it's fast. Some of the use cases of gaze being used are for web navigation, text entry, and also text editing. We decided to conduct a pilot study to investigate the design challenges using voice control in Google Docs. Why Google Docs? Because Google Docs is an extremely popular tool that also uses voice-based typing to convert speech to text. This widely used system has built-in functions for error corrections if speech API transcribes spoken words incorrectly. We did a pilot study with 5 students, and the aim was to collect user feedback on the advantages and disadvantages of such a system in hands-free conditions. What we found out was the students mainly described remembering and recalling commands as a challenge, inability to select a desired word on occurring multiple times. Let's say in a paragraph, if you have apple 3 times, which apple to select? If you say select apple, and inability to select across paragraphs, the same scenario where if you have 2 apples on paragraph 1 and 2 apples on paragraph 2 and you want to select the second apple in paragraph 2, how will you do that? With select function. And effort to navigate across multiple incorrect words was extremely challenging in the Google Docs study. So based on these feedbacks, we devised our voice only approach. We designed an approach with map mode, wherein we were assigning unique numbers to each of the erroneous words. Prediction mode, which showed plausible predictions to selected words, and if it is not there, then there would be a spell mode, wherein people can substitute the currently selected word by just spelling the correct word that they feel.
Map 1 4 Map 1 Spell Fire Finish.
Based on the feedback from the first pilot study, the same participants were asked to use our voice-based approach and give us feedback. The feedback that we received was improved and quicker navigation with our voice-based approaches, faster error correction due to available predictions, additional help from spell mode. But, however, they complained of the repetitive use of the map command which led to discomfort, and also introducing the map command led to an intermediate step in the process of completing the work. From these feedbacks of the second pilot study, we understood that the map-based approach helps in minimizing navigational commands and ambiguity of word selection. However, it introduces an intermediate step in error correction. To reduce this error correction, our design tag augments voice with gaze to facilitate faster error selection followed by correction. Thus, we examined two different approaches to alleviate these problems. One was D-tag, a dwell-based approach, wherein we use gaze as a secondary modality.
Spell. Month. Finish. 2.
Second one was V-tag, wherein we focused on the incorrect word by saying select to select the erroneous word.
Select. 4.
We performed an extensive evaluation on the three different edit methods as discussed, the voice-only approach, V-tag and D-tag. During this process of evaluation, 12 participants performed error correction tasks on 3 blocks. Each block consisted of 5 passages. Each passage consisted of 5 erroneous words. We measured the block completion time, that is the time taken to complete one block, and we found that D-tag performed better than V-tag and voice-only approach with significant results. D-tag was 21.4% faster than V-tag and 25.1% faster than voice-only approach. After evaluating the block completion time, we wanted to investigate how much effort was spent in selecting the erroneous word. The measure is count per erroneous word with a floor value of 1, implying a word was selected on the first attempt. Looking at the selection effort graph, we can also see that D-tag performed better than voice only and V-tag across all the blocks. The first block being the training block for the entire process of evaluation by the participants. It is to be noted that for both block completion time and selection efforts, we did not take into account the first block because of it being training in nature. A subjective feedback session was conducted to understand how participants perceived the interaction with the 3 edit methods. We performed the NASA TLX results, and the scores over here show that VTAG was extremely stressful, and it was much higher task load compared to voice only and DTAG. On interviewing participants, they mentioned that the focus on erroneous words and then speaking the select for VTAG was triggering error corrections was very stressful. An SUS score showed voice only and DTAG to be in the top 10% of all the SUS scores. Participants expressed their comfort in using DTAG as they did not need to focus and say the command or map to select an error. A custom questionnaire was given to understand how participants perceived accuracy, learnability, speed and comfort of the edit methods. Responses scaled from 1 to 7, and as you can see over here, voice only and DTAG scored the same for learnability and accuracy. DTAG performed better on speed and comfort. Another task we adopted was an image description task. This was close to the realistic setup of text creation and editing. This is because prior research argues that evaluation of text entry and editing techniques require free-form input, which is not based on established tasks that we have already done and have been doing it. Traditional approaches of evaluating text-based systems lack the representativeness in natural text entry. It is for this reason we provided participants with an image set from Dunlop et al. Paper where they were shown 3 images and they had to pick any 2 images and describe the images or tell a story that involves those 2 images. This was a free text formation task, and while they were transcribing the text via voice, they had to correct errors. We performed a subjective feedback for the image description task. As can be seen, DTAG performed better in speed and accuracy against all the other edit methods. However, if seen closely, voice only approach was just behind DTAG in accuracy and learnability, and it actually was better in comfort than DTAG. This response is slightly different from the feedback that we received for our edit tasking. Some of the observations that were made during the experimental evaluation of the three different edit methods were improved selection and task completion time with gaze as an additional modality. However, it was also observed that there was difficulty in using gaze to focus and voice to give commands simultaneously, leading to a jitter in selection. The need to have a fallback mode when modalities don't complement each other was also made as an observation by the participants during the experimental study. Some of the limitations that we found during the experimental process were incorrect recognition of keywords, drift of the eye tracker, visual feedback was marked to be necessary by some of the participants, and complex text edits, which is already possible in different text editing platforms like Google Docs. In conclusion, we can say that we presented and evaluated two novel gaze augmented voice based text editing methods. Results show DTAG enabled users to complete tasks with the least time and having higher usability scores and lower cognitive load. 66% of the participants preferred DTAG over edit methods. Thank you for your attention.